Experimenting this morning. Hey, guys.
Hello. Experimenting with Doug Borszynski from the Buffalo Museum of Science. What have we got going on here, Doug?
We're going to do some experiments with water. Earlier I was dropping some drops of water on a penny, and water is unique because it has positive and negative charge. It's bipolar, so it kind of sticks together. On the penny, it's big. It made this big wall. You can actually guess how many drops can fit on a penny.
I don't know, like...
I can do 40.
You can do 40 drops?
Yeah.
I was going to say 5. I was off by a lot.
But here, I got some water here, and what we're going to do is put this little boat in here.
Okay.
And normally on the water, it's going to kind of go towards the middle. Now, what I want you to do is we're going to break the surface tension with soap.
Okay.
So pick up your swab.
Swab.
And you're just going to hit just a little bit of soap.
And is this just regular dish
Yeah, this is just
soap? How much do I need?
Just a little.
Like
now
that?
you're going to put it right behind the boat and watch what happens.
Okay, like here?
Yeah.
Oh, man, the boat's moving!
I love this in my bathtub, personally, as a way to get the water more soapy. Now, if you do it a couple more times, you'll eventually realize that the soap, is actually going to make a really tiny film, and it'll stop working. You try it probably one more time.
One more time? It
but
will work
once that soap completely disperses over the surface...
It's not working.
Nope, that's what happens.
Oh, did I put too much soap on it the first time?
It doesn't take much. But
That's
just
very
enough, it makes a little tiny film on the top, it breaks the surface tension, and now our boat's stuck.
Now, if we were to talk about this on a real-life scale, how big of a swab and how much soap would you need to power a boat?
I don't think you want that much soap in a lake.
Oh, well, who says
Probably
put
not
it in
good
a
for the
lake?
birds.
Maybe a pool?
A pool, oh. You know, I've never tried that.
So what is it about breaking the surface tension that makes the boat go forward?
As the surface tension is breaking behind it, it's actually pushing the water and making this bigger circle, and it's this wave, it's just riding the outside of the wave. As that surface tension is breaking, it's just going with the water. As the water's going away, and you'll see that in our second experiment a little bit later.
Yes. Now, what can kids learn from this experiment? Because I learned, you know, wow, this is cool. I made a boat move with soap.
Water is a universal solvent. Because it's bipolar, it can break apart stuff. There's negative charge, positive charge. It's playing with water. It's the way it sticks together. It's the way capillary action works, because the water sticks together and draws up. It's the way that trees actually get water through transpiration, because that water sticks to each other, then evaporates through the leaves. So the idea of water, it's just amazing the way our planet's formed just because of water.
It absolutely is. We're going to be back with Doug later in the show to do another experiment. We talked about it a little bit, but for now, we're going to go back to Joe and Victoria.
I love that. I'm going to do that with my son when I get home.
Hours of energy.
And this, we're going to watch colors explode in milk, which sounds pretty exciting. So I'm going to get started.
The same properties of the water and that, but this time we're going to do a little different. We're going to add milk.
Okay.
So I'm going to start here with just some whole milk.
All right.
And the nice thing about during the summer, sometimes you just got that little bit of milk left. You don't need much of it that no one wants to drink.
Yeah, I always leave that in the fridge and hope someone else just
Well, now
takes
it's
care of
something
it.
you can do with it.
Good.
Your second helping here.
Yeah, second helpings for science.
So we're just going to kind of make a little circle there. Now, I want you to make a whole bunch of dots kind of in the middle with a different food coloring.
Any color is fine?
Just make a couple different dots. Try different colors.
Ooh.
Try getting more in the middle.
In the middle?
Yeah, you'll see why in a second.
Okay. Did I ruin this one?
Oh, no, no. Trust me. Any experiment I do is never wrong.
Good.
I learn more by being wrong than ever being right. So
well, it happens.
I'm in a good job for that.
Yeah, we do a lot wrong here, but it all turns out okay in the end.
Exactly.
All right, there, that's
Oh, we got to get some green,
dots.
come on.
Oh, I just wanted primary colors.
Oh, I'm sorry.
That's okay, I'll forgive you.
So now we're going to take your little cotton swab, you know, regular cotton swab's fine.
Okay.
Dip a little bit.
Just like that or more?
Yeah.
Okay.
You just need a little. Just going to dip it right in, and let's see what happens. Right in the center. Let's see what happens.
Whoa! Oh, my God! Now, why does that happen?
Okay, it's still the water. You still have this bipolar molecule, but this time there's a whole bunch of fat from the milk. And the fat does not like the soap. So as we added the soap, here, try and dip it again.
Oh, my gosh, when I bring it up, it keeps going.
Yep, try a little bit more soap. See what else can happen.
A little more soap? I don't want to contaminate it. Can I still do that?
There we go.
Okay. More, I just put it in again?
Yeah, try putting more in. There you go. Keep doing it a couple more times.
Will do.
Eventually, the same thing with the boat, though, is that you're going to cover the surface in soap, and it won't work as well.
Oh, yeah, it's kind of stopping already. You can see where the epicenter was.
Oh, good word, epicenter.
Yeah, I got a few of those in my vocabulary bank.
Now, this is basically reacting with the soap and the fat. So we want to know what happens if we increase the fat. Do you think it'll go faster, slower? Do you think we need the water in it?
I don't know. I have no idea, but we have half and half, which has more fat than milk.
Absolutely. So let's do the same thing.
Okay. Just pour. Oh, wow. All right. Is that enough? Do you think?
Absolutely.
Okay, so put some more dots in it. We got to do
Yep,
this
you're
again.
gonna
We
make
only
your
have about
dots.
30 seconds left. Now, we're working on this fun little experiment right here, but you have lots going on at the Science Museum.
Oh, absolutely. I mean, that was a great exhibit. We just heard about the bisons, but we have our own Leonardo da Vinci Machines in Motion. That's actually a traveling exhibit that's up for a while. And then starting to the fall with Journeys into Papa. It's our own collection. Your 100th show today is going to be our 150th year, so we're going to start the
Wow.
fall with an eternal collection exhibit, which is nice. The PGT Black collection is this great collection of South Pacific items, and we put in some of Penny's works that we've bought from him from his collection. It's just going to be a great little celebration of the museum, and later this
Great.
year we have a couple big things coming.
That sounds exciting. I always love the Science Museum. Now we got to see what happens in this half and half.
So you
Just
think
put
it's
it
gonna
down
go
in the middle.
faster?
I do. I think it's going to whip to the sides. That's my guess. No, it's going really slow, but it's amazing. I could just watch this for ages. But sadly, we do have to get on with the show, and I can't just keep watching this. So we're going to send things over to